Hey guys, we are here today to revisit an old tool that we've used before, that being the number bond. So we've used that way back in like kindergarten. You learned about that with addition. You've also used it with subtraction, and this year we've learned about how to use it with multiplication and division. And today we're going to expand that tool's use and use it with fractions. So let's do a quick review about how it's been used in the past before we get into how we can use it with fractions today. So I'm just going to draw a couple of quick examples for you, just to refresh your memory. So like in the past, again, way back in kindergarten, you would have learned that like 5 can be made up of a 2 and a 3, for example, right? The total 5 is the sum of 2 plus 3, right? And then this year we learned that, 6, if we're doing multiplication, as the product of 3 2's. So 2 plus 2 plus 2, or in this case, 3 times 2. And this is 2 plus 3. Well, what we can learn today is that we can have a fraction. We're going to add up to 1. Actually, you know what? I'm going to draw this two ways in here so you can see it. Let 4 fourths equals 1. You won't always see it that way, but I like to show it. We could have like 3 fourths and 1 fourth. Now, this goes right along with the work we were doing yesterday when we were working with diagrams, rectangular diagrams. A portion was shaded, a portion was unshaded, and we were looking to see that when you combine the shaded portion and the unshaded portion, you've completed one whole. So we're going to move from that pictorial representation of one whole with two fractional parts into using a number bond to express that. So let's take a look at our problem set, and we're going to get a lot of practice with this on the front side here. So the sample shows eighths. So you notice I have eighths on my denominator on both. I have 5/8 that are shaded, and I have 3/8 that are unshaded. And if you add up the 5/8 and the 3/8, you've used the whole thing, right? And another picture, it says to draw a different visual model. That's part of our direction. Shows the same thing, that 3/8 and 5/8 adds up to one whole circle. So let's continue that with the next one. So we're working with 1, 2, 3, 4, 5. We're working with fifths. I'm just going to put 1 up in the total because this is going to add up to 1 at the end. And I have shaded 3 out of 5 and unshaded 2 out of 5. I probably did that too small for you to actually see. Let me make it a little bit bigger. And 3/5 plus 2/5 is 5/5, and 5/5 is 1. Another way to draw that would be, we'll use the circle. 1, 2, 3, 4, and 5. So I have 3 shaded, 2 unshaded, and I have made up one whole by doing that. If I combine my 2 unshaded and my 3 shaded, I make up one whole circle. I like using the circles for this. It's an easy representation to show that you've indeed added up to one whole. This time we have, you'll notice, 4 triangles within our 4 smaller triangles within the larger triangle. So I'm going to work up to having one whole. I have 4 parts. 1 is unshaded, 1 out of 4 is unshaded, which leaves 3 out of 4 that are shaded. 3/4 plus 1/4 is 4/4, and 4/4 equals 1. And again, I'll shade in 3 here. So you can see if I take my 3/4 and my 1/4 and add them together, I end up with a whole circle. Moving on. 1, 2, 3, 4, 5, 6. We're working with 6 this time. So I am going to draw a 6th. And my number bond is going to have 1 in the total because I'm going to add up to 1. And I have 3/6 that are shaded, and I have 3/6 that are unshaded. So 1, 2, 3 are shaded, 3 are not. So basically 1/2 is shaded and 1/2 is not. 3/6 plus 3/6 is 6/6. 3/6 plus 3/6 equals 6/6, and that equals 1. And the last one down here shows ninths. So I'm going to have a total of 1. And I have 2 ninths that are shaded. And I have 7 ninths that are unshaded. 1, 2, 3, 4, 5, 6, 7. You can double check. The reason I knew it so quickly is I knew that 2 plus whatever, my other numerator had to add up to 9. So 2 plus something equals 9, because we need to have a matching number in the numerator and denominator to have 1. And I'm going to spare myself trying to draw ninths in a circle, and I'm going to draw them like this. 1, 2, 3, 4, 5, 6, 7, 8. Draw 8 lines, get 9 spots. I'm going to shade in 2 of them. I have 2 ninths that are shaded. I have 7 ninths that are not. 2 ninths plus 7 ninths equals 9 ninths. And 9 ninths is that whole shape. And this is the major concept for today, right? And it's the same concept as yesterday, just now we're drawing number bonds to go with the picture models that we've been working with. All right. Draw a number bond with 2 parts showing the shaded and unshaded fraction for each figure. Decompose both parts of the number bond into unit fractions. All right, here we go. That's a lot of directions. It sounds trickier than it is. Okay. I'm going to draw lines between these because otherwise my drawings are going to get crazy and go next to each other. So basically this is one whole separated into 1/4 and 3/4. What it's saying is it wants everything in unit fraction, which means the numerator has to be 1. And so in this case, we're already there, check, right? No problem. But this case, 3/4, what it's saying is 3/4 is really made up of 3 1/4. So I can break my number bond down even further from these 2 parts and say that, well, the 3/4 is made up of 3 1/4 sections. And so that's our task here. So one whole is made up of 1/3 because 1/3 is unshaded, and 2/3 because 2/3 is unshaded. And your job then is to ask yourself, well, what is 2/3 made up of? What unit fraction is it made up of? Well, the denominator is not going to change. We're going to stick with thirds. So it's 2 1/3. 2 1/3 added together adds up to 2/3. When that's added to one more 1/3, we get 1 whole. So it's just taking what we've done with number bonds one step further. We're being able to decompose or break down a fraction into its unit fraction parts. We have 1 whole here. 2/4 are shaded. 2/4 are not. We need to break down both of these because neither is in a unit fraction form into 1/4 parts. Running out of room here. What you'll notice, I'll draw a line between those two. What you'll notice here is that I end up with 4 1/4 sections to add up to a whole. Here, because I was dealing with thirds, I end up with 1, 2, 3 1/3 sections. You're always gonna, whatever your denominator is, you're gonna end up with that many 1/3 or that many unit fractions. In this case, it was 1/3. The last one is fifths. So I have 1 whole made up of 3/5 and 2/5. 2/5 is then broken down into 2 groups of 1/5 or 2 sections of 1/5, and 3/5 can be broken down into 3 sections of 1/5. And again, we end up with 1, 2, 3, 4, 5. 5 sections of 1/5, 5 1/5 equals 5/5, which equals 1. This is something we'll get more practice doing. Again, it looks messy, it looks confusing, it looks like a lot, but I promise you it's not as bad as it seems once you get some practice doing it. Whatever the numerator is on each side, that's how many unit fractions you're basically going to break it down into. It's as simple as that. So if the numerator is 2, you're going to have 2 unit fractions branching off of that part of your number bond. If it's 4 in the numerator, you're going to have 4 unit fractions branching off of your number bond, or that part of your number bond. I will do one word. There is only one more word problem, but we'll do that together here. The chef put 1/4 of the ground beef on the grill to make 1 hamburger and put the rest in the refrigerator. So I'm going to draw a 2-part number bond showing the fraction of ground beef on the grill and the fraction in the refrigerator. Draw a visual model of all the ground beef. Shade what's in the refrigerator. I'm going to start with this part. I'm going to start with a picture. That's the more basic understanding, like level of understanding, and then I'm going to move to the more difficult level of understanding, or more advanced level of understanding. So I'm going to say that I have a package of ground beef hamburger, and I'm putting 1/4 on the grill. That leaves 3/4. Oh wait, I'm sorry. It said shade what's in the refrigerator. Look at that. I guess I could have just left that shaded and shaded 2 other parts. So 3 parts are in the refrigerator. 1 part is not in the refrigerator. Now I need to draw a 2-part number bond. So 1 whole is made up of 1/4 on the grill and 3/4 in the refrigerator. This is grill. This is fridge. Okay, and we can see 3/4 and 1/4 added together makes 1 whole. We have that whole package of ground beef accounted for now. We know where every part of it is. We haven't lost any along the way. What fraction of ground beef was in the refrigerator? 3/4. That's, once we've done this work, that becomes pretty simple. Just filling it in. We should write that in a full sentence. Like I'm not here, but you should write there are 3/4. 3/4 of the whole is in the refrigerator. How many more hamburgers can the chef make if he makes them all the same size as the first one? Well, the first one he made 1/4, and he has 3/4 left. So I would say I could take that 3/4 and make 3 more 1/4 burgers, or 1/4 pound burgers. So quarter pounders is basically what they're called. So 3 more 1/4 pound burgers. And the last part says, show the refrigerator ground beef broken into unit fractions on your number bond above. Guess what? I'm way ahead. I already did that part. I already included the 1/4 there. And again, that numerator being 3 told me that I was going to need 3 unit fractions branching off of my that section of the number bond. All right, guys, we covered a lot today. This was definitely some new learning. Like, we used a tool that we've used before in the number bond, but we use it in a way that we've never seen it used before. So I expect that there may be questions. I expect that we might have to go over this a little bit more. It's definitely upping the level of complexity a bit from what we've done already with fractions. So please feel free to ask questions. Please stop me in class and ask me to clarify, or ask me to go over problems again. Ask me to do new problems for you, because I understand that this is something that we haven't done before, and that it can be really challenging. So you're not alone if you find that it's challenging, and I'm here to help if you need it. All right, guys, keep up the good work.